Good morning, one and all. Today, we are going to see a circuit on finding out the equivalent resistance. Take down this problem using star to delta transformation. Obtain the equivalent resistance at the terminals A, B of the circuit given in the figure below. So, by seeing this circuit, what you're thinking is, say for example, you will not study this star to delta transformation. Simply, you'll try to resolve this problem. But if you resolve this, if you try to solve this problem, then you might get the wrong answer because here star delta transformation like that clearly given. So you need to find out which part is a star like that. So if this circuit is there now, so this part is the star part because this 10 ohms, this 10 ohms and 10 ohms. So if you redraw the circuit, then this is the star part, and this star part you need to convert to the delta part, and accordingly you need to redraw this circuit and you need to calculate the equivalent resistance. Let's solve this problem. Here, if you see, so what did is I have drawn this particular that 10 ohms is there, na? This 10 ohms. Here 10 ohms is there, here 10 ohms is there, this 10 ohms is there. This 10 ohms I'm drawing in the star format such that we can convert that into delta transformation. So while redrawing the circuit like this is the 10 ohms. Here also I have connected 10 ohms. Here also I have connected 10 ohms. As per the circuit diagram, whatever is there in the circuit diagram, so that points you should not change. So this I have connected to this, and again 20 ohms here, again here 10 ohms, and again this is the 30 ohms, again this 50 ohms. This is all in the circuit. Okay, so you should not disturb all these parts. Without disturbing this, you need to convert the star circuit to the delta format. So that's what we have drawn like this. So this you should not disturb. This should not disturb. We should not disturb. So we have redrawn. So now this is the star circuit. We need to convert into delta. So you know how to convert the star to the delta. Okay, solving with star to delta circuit alone. So how to find out this R1? So R1 is equal to first RA into RB plus RB into RC plus RC into RA divided by RC. So whichever is not there, see this R1. So this RA and RB is there. So whichever is not there, that should come in the denominator. That is divided by RC. So similarly, you need to substitute what is RA, RB. So just for our reference, I have taken this as RA, RB, and RC, such that it will be easy for us to know. So RA I have taken as a, so here 10, RB also 10. So all are 10. Okay. So defaultly by closing eyes, you can write all as 10. But here you need to see in some other circuit, it will be given in the different values. So here you need to verify. So here all are given as 10. So just we are substituting 10. So 10 into 10 plus 10 into 10 plus 10 into 10 because RA is also 10, RB is also 10, RB is 10, RC. So similarly, RC and RA also 10 divided by 10. So this, if you simplify this, you will get R1 as 30 ohms. So similarly, R2. So here, how to find out the R2 here? R2 is nothing but same RA plus RA into RB plus RB into RC plus RC into RA divided by, so whichever is not there. So RA and RC is there. This RB is not there. So divided by RB like that. So similarly, you need to substitute all are 10. Just you substitute, and if you calculate, you'll get this 30 ohms only because here also you got 30 ohms. So here also you, because all are 10, no, so same values only you'll get. So even though we'll try to solve because for clearing your doubt. Next, similarly R3. What is R3 then? Similarly, RA plus RB is RA into RB plus RB into RC plus RC into RA divided by. So here RB and RC is there, RA is not there. So divided by RA. So the same formula divided by RA. So here again you need to substitute all. You need to substitute all the resistance value and we can easily find out what is R3. Now the circuit is redrawn as. So here now what we are doing is previously star circuit was there. If you see here, Yeah, it is star circuit what this. Now we found out what is R1, R2, and R3. That is 30 ohms. So here we are redrawing this circuit. Same circuit we are redrawing. Just we are redrawing with 30 ohms, here 30 ohms, here 30 ohms, here it defaultly 30 ohms is there, here 20 is there, 10 is there, and 15 ohms is there. So now we are reducing the circuit. We are going for the circuit reduction because this 30 and 30 ohms are in parallel, no? So the two resistance are in same value means just divided by 2, or otherwise you can go for 30 into 30 divided by 30 plus 30 also you can go, same answer will come. But if two ohms, two resistance are in parallel, if same values with the same values, just we have to take that value divided by 2. So it is 15 ohms. So similarly this 20 ohms and 10 ohms. Okay, so if you take this 20 ohms and 10 ohms are in series, so this also we converted to 30 ohms. So now this two we converted into 15 ohms, so that we added here. Again 30 is there, that we added here. Here also this two we added here, 30 ohms is there. So as I said previously, to avoid confusion, mark all the points. See now, here I can easily solve this circuit, but as a basic engineering student, sometimes you will get confused whether which two are in parallel, which two are in series, like that. So previous circuits also we have seen just by marking those points. With giving some values, if you mark, say for example, I have marked here as P Q R, like that. So this point I have marked because this R equivalent A across A and B we need to find out. So we can use some different notation. Okay, instead of A B C D, we can use P Q R S, like that. So here this point I marked as P means this also will be P because same wire is continuing here. So this also P. And this junction is different, this node is different. So here I am marking as Q, and this node is different, here I am marking as R. Okay, so this wire is coming as it is to this is Q. Okay, so now with these 3 points we can easily redraw the circuit if you having the confusion. So circuits can be further redrawn as, so P, Q, and R. Okay, so you have to see which are P are connected together. So P means this 30 and 15 are connected. Okay, 30 and 15 are connected to the P. So and 15 is connected to R. This 15 after 15 is connected to R. Okay, so that you are drawing. Okay, so 15 where it is, yeah. 15 is connected to R. This point is R. Okay. Across R and Q, that is 30 ohms. So if you take this as Q, so this is 30 ohms. So that also we are adding over here. Next is, this is same. This is also between the R and Q also 30 ohms. So between the R and Q again 30 ohms is there. So simply we are redrawn the circuit, or otherwise also some expert can directly solve. But why to get avoid your confusion, better it will hardly take half of the minute to mark these points and redraw the circuit. Okay, 1 minute hardly it will take. So easily you can redraw the circuit such that you will avoid all your confusions. Okay, now we have redrawn the circuit. Now if you see this 30 ohms and 30 ohms are in this sorry, this 30 ohms and this 30 ohms, this 30 ohms and this 30 ohms are in parallel. Okay, because this connected in parallel. So if both connected are in parallel and both resistance are same, that's divided by 2. So 30 divided by 2 is 15 ohms. So again further we are reducing like this. Again you draw the circuit fast, no need to draw with scale and pencil, just freehand diagram, clearly you draw. Okay, so now again what we did, we have taken this 30 as it is, this 15 as it is, this 2 reduced to 15. So we redrawn like 15. Now you can easily tell this 15 and 15 ohms are in series. Okay, this 15 ohms and 15 ohms are in series. So 15 plus 15 is 30. So again this 30 and 30. If you see 30 and 30 are in parallel. Okay, you should not draw in. So this 30 and if 15 and 15 is added, this is 30. So again this 13 and 13 are in parallel. Okay, if you draw like this also same, or if you like this also will be same. So 30 and 30 are parallel. So 30 and 30 are in same, like resistance are in parallel. So and having same values means just divided by 2. So 30 divided by 2 is 15 ohms. So again 15 and 15 are in parallel. So if both resistance, same resistance are in parallel means just divided by 2. So 15 divided by 2 is 7.5. So R equivalent across this A and B point is 7.5 ohms. Very simple problem. Sometimes they may ask in 10 mark question also. So easy, and sometimes they will ask in 5 mark question also. Easily you will get marks. So don't think like the circuit is big. It is very tough. How we can perform star delta transformation, like that many questions may come while seeing this circuit, but it is very simple. Okay, first you need to identify which part is star format. So in this circuit clearly this part is star format, so easily you can redraw the circuit like this and you can further solve the problem. Okay, so easily you can get the full marks for if the question like this will come, not only the same question. So whatever the question it may comes, if they tell it is star delta or not, sometimes they won't tell also. So by the time you need to default assume how, which is star. Okay, if you simply solve with this 30 and 10 are in parallel like that, if you solve, then whole problem goes wrong. If this part is not there, then you can solve like this. Okay, if this part is not there, okay, say for example, if this part is not there, okay, so like this is connected like this point is connected like this 2 point is connected like this, then you can solve with your series parallel method and reduce the circuit. Okay, because it's here two stages there. So definitely it might be something will be there. So you need to go for the correct star delta or delta to star, whichever is possibilities are there, that you need to convert, and further you need to proceed and you need to solve the circuit.